At the Onagawa Nuclear Power Station, we hold firmly to the belief that there is no end to improving safety measures. This belief inspires our ongoing commitment to advancing safety and continuously enhancing our systems. Located in the middle of the Oshika Peninsula at the southern tip of the Sanriku coast on the eastern side of Miyagi Prefecture, the station spans Onagawa Town and Ishinomaki City in Miyagi Prefecture. Onagawa Nuclear Power Station has 3 units, Units 1, Units 2 and Units 3. Unit 1 started operation in 1984, is undergoing decommissioning. This process began in 2020 and is scheduled to continue until 2054. Unit 2 started operation in 1995. In May 2024, safety upgrades aligned with new regulations set after the TEPCO Fukushima Daiichi nuclear power plant accident were completed. In November of the same year, Unit 2 resumed operation for the first time in approximately 14 years since the Great East Japan earthquake. Unit 3, which began operations in 2002, is currently in a state of stable shutdown. Total electrical output of Unit 2 and Unit 3 is 1.65 gigawatts. This power station can supply electricity equivalent to about 70% of the total electrical demand quantity in Miyagi Prefecture. The Great East Japan earthquake in March 2011 brought significant seismic and tsunami activity to the Onagawa Nuclear Power Station. Yet, despite these challenges, the plant systems for shutdown, cooling, and containment operated effectively as designed, ensuring that all reactors, Units 1 and Unit 3, which were operational at the time, and Unit 2 in the reactor startup process, were safely shut down. In the aftermath, the station provided refuge to over 300 local residents affected by the disaster, with some staying as long as 3 months living alongside plant employees. After the Great East Japan earthquake, the Nuclear Regulation Authority implemented new regulation in July 2013 based on lessons learned from the TEPCO Fukushima Daiichi nuclear power plant accident and the latest domestic and international knowledge. The application of the new regulation involves 3 key approvals: Reactor Installment License Permission, Construction Plan Approval, and Reactor Facility Safety Regulation Approval. Unit 2 successfully met all these requirements and obtained the necessary permits and approvals, confirming its compliance with the new regulations. We have enhanced our safety measures, incorporating the lessons from the Great East Japan earthquake and the TEPCO Fukushima Daiichi nuclear power plant accident. Allow us to present the 5 key initiatives we have undertaken. To ensure the reactor can be safely shut down, preparation for both tsunamis and earthquakes is especially important. Number 1. Preparation for tsunamis. For tsunami preparedness, we reassess the maximum potential tsunami height to 23.1 meters and built a 29-meter seawall to provide a robust safety margin. This seawall length, approximately 800 meters, including 680 meters of steel pipe-pile vertical wall and 120 meters of cement-improved soil embankment, protecting the plant from large tsunamis. We also added tide barriers around the intake channels to protect the site from seawater flooding. Number 2. Preparation for earthquakes. As part of our earthquake preparedness, we raised the estimated seismic motion around the power plant from 580 gal to 1000 gal, further reinforcing the plant's seismic resistance. The GAL is a unit that expresses the instantaneous force felt by people or buildings. Approximately 6,600 seismic reinforcements were implemented before the Great East Japan earthquake, and an additional 9,000 reinforcements were carried out after the earthquake. Number 3. Preparation to ensure electricity and water. We have made significant improvements to ensure a stable supply of electricity and water for reactor cooling. A gas turbine power generator, which differs in mechanisms from the existing emergency diesel generators, was installed on high ground as a provision for securing electricity. Electricity is generated by combining the generator vehicle and control vehicle. To minimize the impact of large earthquakes and tornadoes, the light fuel oil tanks are installed underground. A 10,000 cubic meter freshwater storage tank was installed on high ground to ensure a stable water supply. We have allocated high-capacity water pumper trucks capable of directly or indirectly injecting water into the reactor or spent fuel pool from the freshwater storage tank during severe accidents. Also, a heat exchanger unit vehicle is on standby to remove heat from the reactor. Should there be a total loss of power, we have installed a high-pressure alternative water injection system that operates on reactor steam without electricity, as well as a DC-driven pump if AC power is lost. Number 4. Preparation for containment of radioactive materials. Safely containing radioactive materials in an emergency is crucial. During the TEPCO Fukushima Daiichi nuclear power plant accident, damage to the primary container vessel and reactor pressure vessel resulted in a hydrogen explosion that compromised the reactor building and allowed radioactive materials to escape. We have taken measures to prevent such incidents. To manage potential hydrogen accumulation from any nuclear fuel breach, we have installed hydrogen recombination devices and filtered venting systems. To prevent primary container vessel damage, we installed a filtered containment venting system that reduces the release of radioactive materials to less than 1/1000th when steam is vented into the atmosphere. Number 5. Preparation for various disasters and risks. Beyond tsunamis and earthquakes, we have taken precautions against various other risks. Anticipating the potential for one of Japan's largest tornadoes with wind speeds of 100 meters per second, we have set up a tornado protection net over the seawater pump room to protect the emergency seawater pumps from damage caused by flying objects. Fire protection measures have also been taken to ensure that in the event of a fire, cables located in the same area as the fire source are not damaged. We covered cable conduits with fire-resistant insulation, and seismic reinforcement were made where necessary to accommodate the added weight from these fire protection measures. To prepare for the risk of a large-scale nuclear accident, we have established a seismic-resistant emergency response building on high ground, acting as a local command post. This facility can house approximately 200 personnel and equipped with communication facilities. Additionally, we have facilities to ensure the plant's safety in the event of a terrorist attack. Following the completion of safety upgrades, Unit 2 has been progressing through the steps required for restarting operations. In September 2024, fuel loading into the reactor was implemented, followed by reactor startup in October. After various inspections, power generation restarted in November 2024, marking the restart of Unit 2 of the Onagawa Nuclear Power Station for the first time in 14 years since the disaster. The station operates 24 hours a day in three-shift system, where employees, also known as operators, are responsible for the station's operation. A total of 8 operators, including and led by the Power Generation Section Chief, consist a team in Unit 2, responsible for tasks such as operation control, monitoring, equipment handling, and inspections. To ensure a rapid response in case of emergencies, a permanent resonance system is in place. Additionally, on weekends and public holidays, staff are on standby within the designated area to ensure swift assembly in the event of an emergency. In the event of a major incident, an emergency response headquarters led by the superintendent is ready to act. Teams are assigned specific functions to ensure a swift and effective response. While advanced safety equipment is critical, the real key to safety lies in the people who operate it. To maintain and improve emergency response capabilities, we conduct regular training for a variety of scenarios. Both now and into the future. By maintaining high standards of preparedness and continuous engagements with local residents, we aim to provide reliable power supply and contribute to regional prosperity while strengthening our relationships with the community.